Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is November 2019, paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. On a circle, which of these is not a straight line? Circle your answer. Okay, so we've got 4 words that are associated with circles, haven't we, here? So what's what? The circumference is the bit around the edge of the circle. The radius is the line that goes from the center to the edge. A chord is a line joining 2 points on your circumference. It was a bit wonky, but it's meant to be a straight line. And then a diameter is a line going from one side of the circumference through the center to the other side. Okay, so diameter, chord and radius are all straight lines. It's the circumference, isn't it, that is the curved one. It's the curved edge of the circle. Question 2. Circle the expression that can be written as 3CD. Well, 3CD just means 3 times C times D, so it's that one on the end there. Question 3. Which 2 numbers, when added together, make a cube number? Circle your answer. I think what I'm going to do is I'm going to just add them all together first to see what we've got then. So 1 plus 8, that's 9, isn't it? 2 plus 4 is 6. 9 and 18 is 27. And 8 and 64, that is 72. So I know straight away which one is the cube number. It's 27, isn't it? Because that is 3 cubed. I do recommend just learning your cube numbers from 1 to 10. So 1 cube, 2 cube, 3 2 cube, 4 cube, because there are lots of questions like this where you just have to pick a cube number out of a list. And if you know what they all are, then it makes it very easy to pick the right one. Yeah, if you haven't memorized your cubes, so this is the calculator paper. So you could just pull up a calculator, type in the cube root, and then put your number in, and it will tell you if it's a whole number or not. So that's another way that you could do it. Question 4. Convert 2.5 kilograms into grams. Well, how many grams are there in a kilogram to start with? 1 kg, that's equivalent to 1,000 grams. So if I've got 2.5 kg, that's going to be 2.5 times 1,000, isn't it? Or 2.5 times 1,000. 2.5 times 1,000 is just 2,500. It's going to be that one there, 2,500 grams. Question 5a, convert 47 over 8 into a mixed number. Well, how many times does 8 go into 47? You can think about this as like division, like you used to learn in primary school, you know, when you worked out how many times a number goes into a number and what the remainder is. That's quite useful for converting into mixed numbers. So you can say that 8 goes into 47 5 times, because 5 times 8 is 40. So it goes in 5 times and the remainder is 7. So the 7 becomes the numerator of your fractional part. Divisor stays the same, it's still 8. So it becomes 5 and 7/8. If you are struggling, you can just do it on your calculator, of course. If you just type the fraction in, so 47 over 8 into your calculator and press equals, it just says it's 47 over 8. But can you see above the S to D button there is like there's a mixed number pointing to a top every fraction. So if you press shift and then that key, it kind of toggles it between a top every fraction and a mixed number. So that's a useful key to know. 5b converts 61 over 128 to a decimal. Again, I'm just going to type that fraction into the calculator. 61 over 128. And then press the yesterday button. We just need to copy that down then. I need to give my answer to 2 decimal places. So I'm going to round off after the 7. The next digit is an, so I've got 0.4765, etc. So if I want to round off after the 7, the next digit is a 6, isn't it? Which means I need to round up. So my 0.47 rounds up to 0.48. Question 6. George buys some food for £16.55. He pays the exact amount with 2 notes and 4 coins. List the notes and coins. Okay. Well, if he's paying £16.55, then the 2 notes are going to have to be £10 and £5, aren't they? Okay, so that's £15, and then I've got £1.55 still to pay. So £1.55 still to find. So how can we make £1.55 out of 4 coins? Well, I suppose if we had like 3 50p's, that would be £1.50, wouldn't it? And then if I had 1 5p, then that would be 55. Okay, so £1.55. So my notes then are £10, £5, and my coins are 50p, 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 5p. Okay, question 7. Choose one of the following to make a correct statement each time. And we can pick from is less than, is equal to, and is greater than. And underneath I've got various algebraic expressions, and I'm told what the value of the letters are in those. Okay, now in order to work these out, I'm going to have to evaluate all of the various expressions first, so that I know what's what. So let's have a look at this first one. When a is 3, 4a blankety blank a plus 7. Well, 4a is 4 lots of 3, isn't it? So this is going to be 4 lots of 3, which is 12. And a plus 7 is going to be 3 plus 7, which is 10. Okay? So is 12 greater than, less than, or equal to 10? It's greater than, isn't it? So I'm going to write down in between is greater than. Okay, next one. B is equal to 8. So 2b minus 6 is going to be 2 lots of 8 minus 6. Well, 2 8s is 16. Take away 6, that's 10. And then I've got 18 take away 6, and that's equal to 12 then, isn't it? So 2b minus 6 is going to be less than 18 minus b. Okay, next one. C is 0.5. So 3c is 3 lots of 0.5, which is 1.5, isn't it? And on the other side, I've got 0.5 plus 1, which is also 1.5. So those two are equal, aren't they? So I'm going to write down is equal to. Then finally, when d is minus 1, d is minus 1. And d squared is going to be minus 1 all squared, which actually is positive 1, isn't it? So negative 1 is less than d squared. Question 8. Write down all the whole numbers that are between 20 and 50 and have a difference of 4 between their digits. Okay, I think what I'm going to do, I'm just going to write them all down. It seems like a lot, but it won't take me too long. 20, 21, 22... Now, which ones have a difference of 4 between their digits? Well, 20 take away 0 is 2, so that one doesn't. 21 take away 1 is 1, no. 22 take away, 2 take away 2 is 0. 3 take away 2 is 1. 4 take away 2 is 2. 5 take away 2 is 3. 6 take away 2, that's 1, isn't it? That's got a difference of 4. No, that's got a difference of 5. That's got a difference of 6. That's got a difference of 7. That's got a difference of 3. That's got a difference of 2, that's got a difference of 1, that's got a difference of 0, 1, 2, 3, 37, 7 take away 3, that's 4. 38's got a difference of 5, difference of 6. Oh, that's got a difference of 4 as well, 40. 41 has got a difference of 3, got a difference of 2, got a difference of 1, got a difference of 0, 1, 2, 3. That's got a difference of 4. That's got a difference of 5. That's got a difference of 5. Okay, so I found 4 of them. So it was a bit long writing them out, but I think that was, you're in. The difficulty here is going to be missing one out. It's not hard to find one, but to find all of them, be systematic, it took me a little bit of time to write down all the numbers, but now I'm pretty sure that I've got all of them. So mine are 26, 37, 40, and 48. Question 9a, rearrange m equals p plus 2 to make p the subject. Well, to make something the subject, we've got to get it by itself, and at the moment I haven't. I've got m by itself and p is part of an expression. But if I take 2 away from both sides, then that will cancel with that, and it will leave me with p on the right, and on the left I'm going to get m minus 2. Okay, so now I've got m minus 2 is equal to p. Now if I spin that around and rewrite it but with p at the front, so p equals m minus 2, then I've got a formula which has got p as its subject. Okay. B, simplify 5x squared minus x squared. So if I've got 5x squared and I take one away, I'm left with 4x squared, aren't I? So it's just 4x squared. Got 5 of them. Subtract 1, I've got 4 left. 4x squared. Question 10. A line joins A, which is at 0.11, and B, which is at 0.61 on a centimetre grid. Okay, and I can see I've got my axes, I've got A and B marked on there. Now I'm told P is a point on the line AB such that AP to PB is in a ratio of 2 to 3, and C is a point such that angle APC is 90 and PC equals 4. Write down the coordinates of 2 possible points for C. Okay, well I think I'm going to sketch it first on the right rather than going to draw until I have a better idea what's going on here. So P is a point on the line AB such that AP to PB is equal to 2 to 3. Okay, so P is a point on the line, and so A to P is 2 parts, and P to B is 3 parts. So if you took this line and divided it up into 5 bits, 1, 2, 3, 4, 5, then P is going to be there then, isn't it? So 2 parts to 3 parts. So P is going to be part way along the line AB. And then C is a point such that angle APC is 90. So A to P and then up to C, well it could be C is up here somewhere. Okay, and it says that PC is 4. So C could be up here with a distance of 4, or it could be down here with a distance of 4. Okay, so it's one of those 2 locations. So let's mark P on. Now we know what's going on. So 2/5 of the way along that line. Can you see there are 5 squares between A and B? So P is going to lie here, isn't it? Okay, and then my point C is going to be 4 units above that. 1, 2, 3, 4. So it could be there. I'm going to call that one C1, or it could be 4 below. 1, 2, 3, 4. It could be down there. It could be that one. Okay. So what are those 2 coordinates? C1 is at 3, 5, so it could be 3, 5, or C2 is down there at 3, minus 3, so it could be 3, minus 3. So they're my 2 possible coordinates for C. Question 11. At a school there are 6 lessons in a day. In total, the 6 lessons last for 5 hours. Assume that each lesson lasts the same amount of time. How many minutes long is the final lesson? So if each lesson lasts the same amount of time, then we just need to take the total amount of time and divide it by the number of lessons, and then we'll know how many lessons we've got altogether. Okay? So he wants to know in minutes. So I think the first thing I'm going to do is going to take my 5 hours there, look, and then convert it into minutes. So there are 60 minutes in an hour, and I've got 5 hours. So 5 lots of 60, that's 300 minutes, isn't it? Okay, so just going to do that unit conversion first. And then if I've got 6 periods and I want to work out how long each one is, then each lesson is going to be the total amount of time for the day, which is 300, divided by the total number of lessons, which is 6, and 6 goes into 300, I know, 50 times. Don't believe me? Type it into a calculator. 300 divided by 6, that's 50. Okay, so that's 50 minutes. So 50 minutes. Part B says, in fact, the first lesson of the day lasts longer than the other lessons. The other lessons last the same amount of time. What does this tell you about the length of the final lesson? Tick one box. It is shorter than the answer to part A. It's the same as the answer to part A. It's longer than the answer to part A. Okay. I think it's going to be shorter, because before we had like 6 equal 50-minute sessions, didn't we? Okay, so 50, 50, 50, 50, 50. But what we've done is we've increased that first one. I'm not sure by how much. Let's say we increased it to 60. Then that extra 10 minutes is going to have to come out of these classes here then, isn't it? These are all going to stay the same. I've got to borrow 10 minutes, so probably what I'm going to do is make all these ones 48, 48, 48, 48, 48, and that's going to give me 2, 4, 6, 8, 10 minutes to give to the first period here. That's not really important, but the important thing is, look, is the time has to go down. Okay, it has to get shorter because we have to take some time off of the 50 to give to that first period. So it is shorter than the answer to part A. Question 12. A bottle contains 1.5 litres of water. 650 millilitres of the water is poured into a jug. How much water is left in the bottle? State the units of your answer. Okay, do you notice we've got mixed units here? I've got 1.5 litres here and 650 millilitres here. I think I'm going to convert everything into the same unit first, and I think the unit to go for probably is millilitres, because then I won't have any awkward decimals or anything. So 1.5 litres is the same thing as how many millilitres? Well, I know there are 1,000 millilitres in 1 litre. So if I've got 1.5 litres, then I'm going to have 1,000 millilitres and half of 1,000 millilitres, which is 1,500 millilitres, isn't it? Or just multiplying through by 1,000. 1.5 times 1,000 is going to give you 1,500. Okay, and then I'm going to do some subtraction, aren't I? So water left is going to be the amount of water that you had to start with, 1,500 minus the water that we're pouring away. We're pouring into the jug. So what's 1,500 divided by 650? Now, if you can do that in your head, 850, I can, so I'm just going to head and do it. But remember, it's the calculated paper, so you can always double check it on a calculator. 1,500 minus 650. Yeah, that's 850. Question 13. The cost of 5 kilograms of potatoes is £3.20. The cost of half a kilogram of carrots is 29p. Work out the total cost of 12 kilograms of potatoes and 1.5 or 1.5 kilograms of carrots. Okay, so let's start with the potatoes. So we've got 5 kilograms costs £3.20 and we want 12 kilograms. Okay, so what we're going to have to do is, well, I think what we're going to do, I'm going to use the unitary method, which is a ratio approach. So if I know that the weight to cost ratio of my potatoes, 5 kilograms costs £3.20. Now we want 12 kilograms, so we want to change that 5 to a 12. Now the unitary method is called the unitary method because you go via 1, which is like the unit length. So in order to do that, we're going to take our 5 kilograms, going to divide it by 5, and that will tell me 1 kilogram, and we're going to times it up by 12 to get 12. Okay, we're going to do the same thing with the other side. So we're going to start with £3.20 for the cost. We're going to divide it by 5 to find the amount for 1 kilogram. 3.2 divided by 5. So that's 64 pence per kilo. And then we're going to take that and we're going to multiply it up by a factor of 12. Actually, you don't really need to write down the middle one if you don't want to. It's just the last one we're interested in. It's the £7.68, 7.68. So that's going to be the cost of the potatoes. So potatoes are going to cost £7.68. Now let's go on to the carrots. Half a kilogram of carrots is 29p. We want 1.5 kilograms of carrots. Okay, I suppose I could do it as a ratio while we're on ratios anyway. So the weight of a half a kilo for carrots is 29p. So we want 1.5. Okay, well, how many times more than a half is 1.5? It's actually 3 times more, isn't it? So if I multiply this up by 3 as well, I'm going to get the cost of the carrots. So 29, 0.29 times 3, basically 0.29 times 3, that comes to 87 pence, 0.87. Okay, so that is going to be the cost of my carrots there. So then the total cost, that's going to be the cost of the potatoes, £7.68, plus the cost of the carrots, 0.87. So that was that one. That was that one. Add them together. Calculator. What's 87p and £7.68? Apparently that's £8.55. That's our final answer, £8.55. Question 14a. The term-to-term rule of a sequence is add 4 and then divide by 2. The first term of the sequence is 36. Work out the third term. Okay, so I kind of use the notation U1 to represent the first term, which is 36, and then U2 is going to be my second term. Now I get my second term U2 by taking the first term, 36, adding on 4, and then dividing by 2. Okay, so what's 36 plus 4? That's 40. Divide by 2, that is 20. And then U3 is I'm going to take my last term, which is 20. I'm going to add 4, and then I'm going to divide by 2. So 20 plus 4 is 24. 24 divided by 2, that's 12. Okay, so that's my third term then, it's 12. Part B says the term-to-term rule for a different sequence is divide by 3 and then add 10. The second term of this sequence is 60. Work out the first term. Okay, so I'm going to express this as a bit of a function machine. I've got my first term here, and then it goes into a function machine where it's divided by 3, and then add 10, isn't it? 10 is added to it, and I get my second term out. Okay, now I'm told my second term is 60, so I want to work backwards and work out what my U1 term is. Okay, so if, like, working backwards, I got the answer 60, and I got the answer 60 by dividing by 3 and then adding 10. So if I kind of work backwards, if I subtract 10 first from 60, that means that 50 must have come out of the first box, been fed into the second box, 10 was added to it, and I got 60. Okay, so doing the opposite of that is kind of like the opposite of adding 10. It's taking 10 away, so going backwards it's taking 10 away. And again, from going from here to here is the opposite of dividing by 3. It's going to be timesing by 3. So my 50 times by 3 should give me 150. So then if I've got 150, I divide it by 3, I'm going to get 50, and I add 10, I'm going to get 60. So that means U1 is 150 then, isn't it? 150. Question 15. The table shows the cost of hiring a concrete mixer for up to 5 days. So you've got number of days in the table and the cost. 14, 24, 34, 44, 54. Eva hires the concrete mixer for 5 days. She says the rate is £14 per day because the cost for 1 day is £14. Is she correct? Give your answer. Give a reason for your answer. No, that she's not correct, is she? The rate is £14 for the first day. If you have a look at subsequent days, it's not £14 more. The difference between 14 and 24, that's like it's £10 more, isn't it? And that's £10 more. So it's actually £10 a day plus £4 extra for the first day. So my reason is £14 is the rate for the first day only. Subsequent days are charged at £10 extra. Either is wrong. Okay, so either is wrong. £14 is the rate for the first day only. Subsequent days are charged at £10 extra. Question 16. X is a negative number. Which statement is correct? Tick one box. The first box says x plus 10 is always positive. Well, if x was, let's say x was negative 5 and I added 10 to it, I'd get 5, wouldn't I? And that is positive. But if x was, so that would be true. But if x was, I don't know, minus 20 and I added 10 to it, then I'm only going to get as far as minus 10. So that is not true. So this statement here is sometimes true, but not always. So I'm not going to tick that one. Okay, x plus 10 is always negative. Now again, if I had negative 20 and I added 10, then that would give me negative 10, and that would be negative. But if I had negative 5 and I added 10, that would be 5, and that isn't negative. So again, that one is not true because it's only true for some values. X plus 10 cannot be 0. Well, it could be, couldn't it? Because if x was 10, if x equals minus 10 and I added 10 to it, then I'm going to get 0. So that's also not true. It could be 0 for that one particular case. X plus 10 could be positive or negative or 0. Yeah, well, I think that's the conclusion we've reached, isn't it? Because if x is negative 5 and I add 10 to it, I'm going to get a positive number. If x was negative 20 and I added 10 to it, I'll get a negative number. If x was negative 10 and I added 10 to it, I'm going to get 0. So all of those things are possible, which is why I'm going to tick that box there. Question 17. The table shows the number of films watched 1 week by 30 people. Okay, so we've got a table. So 5 people didn't watch any films, 9 watched 1, 8 watched 2, 6 watched 3, and 2 of them watched 4 films. And we've got a total at the bottom of 30. That matches the 30 up here that we were told earlier. Okay, so write down the modal number of films watched. Now mode means most, doesn't it? So what was the most frequently viewed number of movies? So it's not this one, that's not the mode, because it's the most, it's the biggest. The mode is the one that the most people watched. Now if you have a look at the frequencies, the highest frequency was 9. So 9 people watched 1 movie, okay? So that was the highest number of people who watched any given number of movies. So the mode is not 9, it's 1. It's the number of movies that the most people watched. So it's 1. B, work out the mean number of films watched per person. So we have to do a little bit of mathematics here, obviously. Now when you're calculating mean from a frequency table, we need to multiply together the number of items, you know, the value plus the frequency, don't you? Luckily we've been given an extra table on the end here, so this is our fx column. So 0 times 5 is 0, 1 times 9, that is 9, 2 times 8, that's 16, 3 times 6, that is 18, and 4 times 2, that is 8. So we're going to add all those up. So 0, 9, 16, 18, and 8. Let's just tap that into the calculator. It's quite long. So 9 plus 16 plus 18 plus 8. That comes to 51. Okay. So that means that number represents the number of films that everybody watched in total. Okay. So there were 51 films watched by those 30 people. So then the mean number of films watched is going to be the total number of films, which is 51, divided by the total number of people, which was 30. So 51 divided by 30. So 51 divided by 30. Apparently that's 1.7. 1.7 movie. Okay, I would be annoyed if I had to watch 1.7 of a movie. But there we go. That's the mean. 1.7. Question 18. Jenny leaves home at 6. Presumably that's AM. She runs for 3 hours. here is the distance time graph of her run. So we've got time along the bottom. It starts at 6 and goes up to 12 midday, and then up the side we've got distance from home measured in kilometers. Okay, so how far from home was she after 3 hours? So where's 3 hours on the dial here? So I've got from 6 to 7 would be 1 hour, to 8 to 9 it'd be 3 hours, wouldn't it? So at 9 o'clock then, she's up here. Let's just draw that on. Okay, and then you can see at that time she's 20 kilometers from home then, isn't she? Okay, that's 20 kilometers there. So how far from home is she after 3 hours? 20 kilometers. Okay, now part B, for the next hour she rests, then she gets on a bus home and she arrives home at 11:30. Complete the distance time graph. Assume that the bus travels at a constant speed. Okay, now we've got two kind of sections to our travel graph already. She starts off at a good running clip here, didn't she? So this is like the first stage, and then so she obviously had lots of energy. It was running nice and fast, and then for the second part of the run, look, she kind of slowed down a bit because the gradient of the line is the speed that you're running at. And then then she gets to this 9 o'clock part here where she's 20 kilometers from home, and then she has a rest for 1 hour. Now if she's resting, she isn't moving, so she's going to flatline there, isn't she? She's not going to get any further away from home or any closer. She's just going to stay there at that same point for an hour. So that would take us up to 10 o'clock, wouldn't it? Okay, so it's just going to be a flat line between 9 and 10. And so that's our third phase of the journey, stage 3, where she's just resting. And then the final stage, stage 4, she's traveling home by the bus, and she arrives home at 11:30. Now 11:30 is here, isn't it? So she's arriving home, so she's 0 away from home when she's arrived home. And if we're going to assume that she travels at a constant speed, then we're going to do a straight line then between those 2 points, aren't we? So the final stage, we are just traveling down like that to home again. Okay, and that's the end of our journey. So that's my completed travel graph. Question 19, S and T are rectangles. S has dimensions x plus 2 and x. Some of the rectangles make the larger rectangles shown. Work out an expression for the perimeter of T. Give your answer in its simplest form. Okay, well this looks like lots of fun. Okay, so we want to work out the perimeter of T. Now T is here, look, it's this one. Okay, now we know nothing about T at the moment. We haven't been given any of T's dimensions, but we can see how it ranks to this rectangle S. And we can see like the distance from here across to here is the same thing as that distance plus that distance. So it's two lots of S along, isn't it? Now we know that S has a side of x plus 2 and x plus 2. So then the side T there then is going to be x plus 2 plus x plus 2. It's going to be those two added together then, isn't it? Okay, so for my T, let's just draw another rectangle out of the diagram. Let's just draw it up here, got a bit of space up here. So this is my rectangle T, and I know that this side here then is going to be x plus 2 plus x plus 2, which is equal to, collecting like terms, I've got an x and an x, and I've got a 2 and a 2. So collecting the x together, I'm going to have 2x, and collecting the numbers together, I'm going to have 4. Okay, so the bottom length of that one is 2x plus 4. Okay, now what about the other side? Now I know that this side of S is x, isn't it? That's x. And the long side of S is x plus 2. So if this is x and this is x plus 2, then kind of that part of it from there to there is going to be the difference between x plus 2 and x. Okay, So what is the difference between x plus 2 and x? That means that this bit down here must be the plus 2 then. If that's the x part, then this must be the plus 2 down here. So that means that's 2, that means that's 2, and that means the side of my T rectangle is 2 there. Okay, so now I know both sides of my rectangle. One is 2 and one is 2x plus 4. So then the perimeter of T, PT, is going to be those 4 sides of my rectangle added together. So it's going to be the 2 plus the 2x plus 4 plus the 2 plus the 2x plus 4. Okay, the 4 sides added together. Now again, I'm going to collect like terms together. So I've got a 2x and a 2x. That's going to give me 4x, and I've got a bunch of numbers. I've got 2, 4, 2, and 4. That should be a plus on the end, look like a minus. So 2 plus 4 is 6, plus 2 is 8, plus 4 is 12. So my total perimeter for P is going to be 4x plus 12. Question 20, I've got the ratio of A to B given as 7 to 1, and I need to circle the correct equation. Is A equals 7 lots of B? Is B equals 7 lots of A? Is A 6 lots of B? Is B 6 lots of A? Now, students find converting between ratios and equations very confusing because if the ratio of A to B is 7 to 1, then that means that A is 7 times as big as B. Does that make sense? A to B is 7 to 1, so A is 7 parts for B's 1 parts. So however big B is, A is 7 times bigger. Okay, so if I was to write that down as an equation, that would say that A is 7 times bigger than B. In other words, A equals 7B. Okay, so the one we want is this one here. Now I say this really confuses students because if you look where the numbers are now, I've now got the 7 there next to the B, whereas before it was on the other side, on like the A side. So that kind of confuses people. They naturally kind of go for that one there, but it's not the right answer. And if you figure it through like I kind of explained it at the beginning, you'll see why. Ratio of A to B means A is 7 times bigger than B, so A is 7 times bigger than B. Okay, that's the answer. Question 21. A spinner has 5 equal sections. Yes, it does. And write a number in each section so that the numbers are all different factors of 100. Probability of a single digit number is 3/5, and the probability of a multiple of 25 is 1/5. Okay, so let's just go through this line by line because I'm a bit confused at the moment. So the numbers are all different factors of 100. So what are the factors of 100 first off? 100 factors of. That's 1 and 100, 2 and 50, 3, no, 4, yep, 4 and 25, 5, yep, that's 5 and 20. Any more? 6, no, 7, no, 8, no, 9, no, 10. Yes, 10 is a square number, isn't it? 10 matches with itself. So I kind of met myself coming down the other way. So they are all the factors I've got to pick from. So all my sections have got to be a number from there. Okay? Right, second thing. Probability of a single digit number is 3/5. Okay? So that means I'm going to have 3 single digit numbers on my dial and 2 double digit numbers. So 3 singles and 2 doubles. And the probability of a multiple of 25 is 1/5. So the multiples of 25 are 150 and 25. So I can have any of those once. I can only have one of these then, can't I? I can only have one multiple of 25, because if I had 150, they would both be multiples of 25, and that would be too many. So I'm going to pick one multiple of 25, so let's say that one, and three single digit numbers. So let's say I go for that one, that one, that one, and then I need one more number to pick. I can't pick any of those because they would be multiples of 25 as well, so I have to pick that one. Okay, because that's the only, well, I could have 10 as well, I suppose. Yeah, I could have had 10, but I'm going to pick 20. So does that meet all the different criteria? So the probability of getting a single digit number, 3 of them out of 5, that's all fine. Probability of multiple 25, 1 out of 5. Yeah, so let's put those in. So 1, 2, 4, 20, 25. Now that's not the only solution, is there? I could have had any combination of 1, 2, 4, and 5 as my 3 single digit numbers. There's no other restrictions other than I need to have 3 of them. So I could have picked like 2, 4, and 5, or 1, 4, and 5. And I could have picked, I have to have 25, 50, or 100, one of those 3, and I have to have either 20 or 10. Okay? So yeah, there are lots of different combinations that do fit, but that is one that does fit. Question 22, here is a small cuboid and a cube. So my cuboid is 2 by 6 by 2, and the cube is of side 2. Small cuboids and cubes are stacked in layers to make large cuboids. Here is a cuboid made with 4 layers. The pattern is continued to make a cuboid with volume 336 cubic centimeters. How many cubes are used? Okay. So this pattern is going to continue. So presumably we're going to keep putting like a long cuboid on the top, and then 3 smaller cubes on the top, and a long cuboid and 3 smaller cubes. Okay, so presumably like the footprint of the shape stays the same size. We're just going to stack on top of this shape as we kind of build up. Okay, so if you imagine the footprint of this cuboid, okay, it's gonna, what is the area of the base of this cuboid? It's going to be the same as the top, and that is, it's like 2 by 2, 4, 6, isn't it? It's 2 by 6. So the area of the top face is the same as the area of the bottom face. That is 2 times 6, which is 12 centimeters squared. Okay, so and then if I know the volume of my shape is 336, then that means that the kind of the cuboid that I'm going to build, the kind of big long tall one, is going to be 2 by 6 times by and this long length here then is going to be 336 divided by 12 then, isn't it? Okay, because the area is 12, and if the total volume is 336, then I'm going to get the height by dividing 336 by 12. Okay, so the height of this shape is 336 divided by 12. So tall tower at 28 centimeters tall. Okay, so it's going to be equal to 28 centimeters tall. Okay, now let's have a look at how this tower is made up. So I've got a long block here which is of height 2, and then I've got the cubes which are of height 2, long block of height 2, cubes of height 2. Okay, so I'm alternating. So how many rows am I going to have higher than if it's 28 centimeters tall? Now each row is the same height, it's all 2, 2, 2, 2, 2. So that means I'm going to have 14 rows altogether then, aren't I? Because if I take 28 and divide it by 2, 28 divided by 2 equals, so the number of rows is going to be 28 divided by 2, it's going to be 14 rows. Okay, so I'm going to have 14 rows tall, and every other row is a row of cubes. So rows of cubes is going to be half that, isn't it? Because it's half of them are going to be cuboids and half of them are going to be cubes. So 14 divided by 2, that means I've got 7 rows of cubes. Now in each row of cubes I've got 1, 2, 3 cubes, haven't I? So in each row I've got 3 cubes. So the total number of cubes is going to be my 7 rows of cubes multiplied by my 3 cubes in each row, give me a total of 21 cubes. Okay, so I make it that there are 21 cubes in total. Tom is tiling a wall. He needs to buy at least 100 tiles. The tiles are sold in large packs and small packs. Large packs come in 40 tiles and they're £18. Small packs come in 28 tiles and they are £14. And there's a special offer on at the moment, 25% reduction when you buy 3 or more large packs. Okay, so work out the cheapest cost for Tom to buy the packs of tiles he needs. Okay, well, there are different combinations he could use, isn't it? So the large pack has got 40 in it and the small pack has got 28. So one possible way would be 3 lots of the large ones. That would be 40, 40, 40, wouldn't it be 120? And that would qualify for the discount, so that's possibly a cheap way of doing it. 28 tiles. We could do 4 packs then, couldn't we? Do 4 of the small ones. That would also give me enough tiles. 100, just over 100, wouldn't it? Be 112. Or there should be some combinations we can do as well. We could buy 2 large and a small, so 40 is 80, and then the 28, that's going to give me 108 tiles. That should be enough as well. Are there any other combinations? So 3 large ones, 2 large ones and a small one. Is there 1 large one? 1 large one would be 40 tiles, and then could we make, we'd need we wouldn't have quite enough for 2, would we? We'd have to have 3 small ones. I think that's going to be a little bit cost prohibitive, that one. Or we can have 4 small ones, no large and 4 smalls. Okay, so they're the 4 different combinations. I'm doubting large plus 3 smalls is going to be the best. Now let's work out those different combinations. Okay, so let's try working out 3 large ones to start with. Now 3 large packs, it's going to be 3 lots of 18. Now remember though, we get to apply the £25 reduction, 25% reduction. Now if you've got 100% and you reduce it by 25%, that leaves you with 75%, and 75% as a multiplier is 0.75. Okay, so to work out the cost here, I'm going to multiply it through by 0.75 at the end. Okay, so 3 times 18 times 0.75. That one comes to £40.50. Okay, it's in pounds and pence. I should really put 2 decimal places after the point. What was the next combination? 2 large and a small. That's going to be 2 times 18 plus the 14 then, isn't it? So 2 18s plus the 14, that comes out to £50. Okay, so I think that the 3 large ones are going to be the cheapest then, so that's 50. Let's just double check the other combinations. We could have a large and 3 smalls. Large and 3 smalls. That's right up here because I ran out of space. It's 1 lot of 18 plus 3 lots of 14. So 3 14s, 14, 28, 38, 42, and 18. That's £60. Finally, we can have 4 small ones. 4s, which is just 4 lots of 14. So times it by 4, double and a double again. 14, 28, 56. That's going to be £56. Okay, so we've got all the different combinations now. Just need to pick out the cheapest one. It's that one there with the discount, isn't it? £40.50. So that one there, cheapest. B, Tom is also tiling a floor. Oh, he must be bored in lockdown or something like that, and taking up his time with lots of DIY. Good job, Tom. Now, the floor is a rectangle with length 600 centimeters and width 240 centimeters. Each tile is a square with side 40 centimeters. Tom uses this method to work out the number of tiles he needs. So the number of tiles that will fit along the length is 600 divided by 40, which is 15. Is that right? 600 is the length, and each tile was 40. Yes, so if I do 600 divided by 40, I'm just going to check his maths as we go along. So yeah, that is 15. Okay, I'm happy with that, and I'm happy with the answer. The number of tiles that will fit along the width is 240 divided by 40. So 240 divided by the same 40. So that is correct. Let's just double check the maths. 240 divided by 40. 6. Yep, that's good as well. So the total number of tiles needed, 15 plus 6. Huh? Tom, what are you doing? That's not right. That is not correct. Because it's basically a grid, isn't it? So you're going to have 15 rows this way and 6 rows this way. So you're going to have to multiply them together, aren't you? It's going to be 15 times 6. Okay? So that's what we need to write. That's his error. So Tom has added instead of multiplying. An equilateral triangle has side length 16 meters. Using a ruler and compasses only, construct a scale drawing of the triangle. Use the scale 1 centimeter represents 2 meters. Okay, so if I'm going to be using 1 centimeter representing 2 meters, 16 divided by 2 is 8. So each side is going to be 8 centimeters in length. So first off, let's just draw the baseline with a ruler. Just drawing out 8 centimeters in length. Okay. Next, using your old short dumpy pencil that you've saved, set your compass up. Don't forget to put the point of the compass and the pencil tip in the same point when you tighten it up. And again, set the aperture of your compass to the same 8 centimeters because it's going to be an equilateral triangle. All the sides need to be the same. And then stick the pointy end of the compass at one end of your line. Don't forget to hold it from the tip. That's how you're meant to hold it. Okay, you can twirl it around, draw one of your arcs, move to the other point, the other end of your line, and draw a second arc. And you should find that the two arcs form a little cross. Okay, and then the next thing you can do is just join that point that's made there with the ends of your line, and it should form your equilateral triangle. Now, as long as your compass didn't stretch while you were drawing your arcs, you should find it is now spot on 8 centimeters, and the job's a good one. Okay, don't forget to leave the construction marks there visible, though. The examiner needs to see those to give you the full mark, so don't rub those little cross lines out. In a choir, there are 35 men and 48 women. The probability that a man chosen at random wears glasses is 2/5. The probability that a woman chosen at random wears glasses is 3/8. Work out the number of people in the choir who wear glasses. Okay, well, probability is equal to successful outcomes divided by total outcomes. Okay, that's the probability formula. Let's take this first one. The probability that a man chosen at random wears glasses is 2/5. Okay, so that means the probability of man glasses, not grasses, glasses, successful outcomes over total outcomes. Well, we know that the total outcome is the number of men there are to pick from, so that's going to be 35. Okay, and we know that we've been given the probability here, which is 2/5. So then what must go here then? Okay, well, if you think, how do I get 35 from 5? I have to multiply that by 7. So if I do the same here, then it must be 14 men wearing glasses then, mustn't it? Okay. We can do the same thing for women as well. So the probability of woman glasses, that is going to be something over the total number of women, which is 48. And then we know that that is 3/8. Okay, so again, How many times does 8 go into 48? That goes in 6 times, so multiply that up by 6. And that's going to give me 3 lots of 6. That's 18 women wearing glasses. So then the total is going to be 14 plus 18 then, isn't it? Which is 28, 32. Okay, so the answer is 32. Part B says a person is chosen at random from the choir. Work out the probability that the person does not wear glasses. So probability of not glasses, that's 1 minus the probability that they are wearing glasses, isn't it? Okay, which is 1 minus, we know that there were 32 people now who wore glasses in the choir, and there is a total number of people of 35 plus 35 men and 48 women, isn't it? Okay, so that's 1 minus 35 plus 48. That's 83 people altogether. So 32 out of 83 wear glasses. So taking that away from 1, so 83 take away 32, that's 51, isn't it? So that's 51 over 83. 51 in 83, that's the probability that the person does not wear glasses. We've been given the formula for density. Density equals mass over volume. We're told that the mass is divided by 2 and the volume is multiplied by 4. What happens to the density? So the mass is divided by 2, be dividing by 2, and the volume is multiplied by 4. Well, if we're multiplying the volume by 4, the volume is part of the denominator, isn't it? So if we're making this 4 times bigger, that also is the same thing as dividing by 4, isn't it? So we're also going to be dividing by 4 again. So we're actually going to be dividing everything by 8. Okay, so we're halving the mass, so the numerator is going to be half as big, which is the same thing as dividing it all by 2. And the volume is going to be 4 times bigger, which means the denominator is 4 times bigger, which means we're dividing by 4 more. So dividing by 2, dividing by 4 is the same thing as dividing by 8. So it's that one there. Solve the simultaneous equations. Now this is a very easy, straightforward simultaneous equation, because look, I've got a 2y there and 2y there. So I can just eliminate the y straight away by subtracting these two equations from each other. So subtracting like with like, 7x take away 3x, that's 4x. 2y take away 2y, they're going to cancel each other out, aren't they? They're eliminated. And then finally I've got 36 minus 16, that is 20. So that gives me 4x equals 20. Now I just need to divide both sides by 4. So that's going to give me x is equal to 5. Okay. Are we done? No, we've only got half the solution here. We found x, but we now need to find y. We can do that by just picking one of our equations and subbing x equals 5 into it. Let's just take the first one. So let's substitute x equals 5 into, well, this is equation 1, this is equation 2, so we can say into equation 1. So 7 lots of x, 7 lots of 5 plus 2y is equal to 36. Well, 7 5s are 35. And then if I take 35 away from both sides to get rid of that 35 on the left, that is going to leave me with 2y is equal to 1. So dividing both sides by 2, I'm going to get y is equal to half, aren't I? Okay, so then the solution is x equals 5, y equals a half. Okay, now at this point, you can just check it by shoving it into the other equation. Okay, always a good idea to do this. It's better to check it in the exam rather than when your results come back. We worked out using equation 1, so let's just check it in equation 2. So we're just going to sub in both numbers and make sure it's true. So 3x, 3 lots of 5 plus 2 lots of y, 2 lots of a half, is that equal to 16? Well, 3 5s are 15, 2 halves are 1, and 15 plus 1 is 16, so that is okay. So that's just a quick way of checking that you've got the right answers. Let's move on. The pie chart shows the information about the people at a theme park. So we can see that the vast majority of people here are going to be children, and there's some women and some men. There are 450 more women than men. Work out the number of children. Okay, so there are 450 more women, sorry. So if we have a look at the angles in the center, women are 65% and men are 35%. So the difference in their angles then is going to be 65 subtract 35, which is 30 degrees. So the women sector is 30 degrees wider than the men's one. So that must be the 450 more women that there are than men. So that means that 450 people is represented by 30 degrees. Okay, so then we can work out how much 1 degree is then. So 1 degree then would be 450 divided by 30, which would be 45 over 3 is 15. So what's the angle for the children? This is going to be, angles at a point add up to 360, don't they? So if I take away the other two, the 65 and the 35, that'll tell me what the angle is for the children. So 65 plus 35, that's 100, isn't it? 360 subtract 100, that's 260 degrees. So then the number of children then is going to be 260 degrees multiplied by 15 children per degree. So what's that? 260, I think it's 3,900. Let me just double check. 260 times 15, 3,900. Okay, the graph shows how much Molly is paid for working for up to 40 hours. She receives a basic rate of pay for the first 35 hours worked and a higher rate of pay for the next 5 hours worked. Okay, so you can see that the gradient is steeper in the last 5 hours, isn't it? So this is going to be her basic pay from here to here. And this bit up here where it kind of the gradient increases, that's the higher rate of pay represented by the higher line on the graph. Okay, so what do we need to do? We need to work out the difference between the higher rate of pay and the basic rate of pay. Give your answer in pounds. Okay, well the rate of pay is going to be the gradient of the line, isn't it? So all I really need to do here is work out the gradient of this triangle here and the gradient of this triangle up here and compare them. So this is the basic rate down here then. So change in y over change in x, the height of this line here, can you see it goes up to, well, this is 250. There are 5 individual divisions between 250 and 300. So each one's going to be worth 10. So then the height here is 280 and the width is 35. So the basic rate is going to be 280 divided by 35. Okay, change in y divided by change in x. So 280 divided by 35. That's £8 an hour then. That's her basic rate. Okay. Now the higher rate is we're going to work out the same thing. We're going to work out the gradient of this little triangle up here. So this goes from 350 down to 280. So that spans 70 in that direction and 5 hours in that direction. So then the higher rate is going to be, well, what's it going to be? It's going to be £70 divided by 5 hours. which should be £14. Okay, we done? No, because we want to work out the difference between the higher rate of pay and the basic rate. Okay, so we need to work out the difference then. So the difference is going to be equal to the higher rate subtract the basic rate. So it's going to be £6. Okay, so she earns £6 more. Work out the ratio of the cube root of 512 to the reciprocal of 0.4. Okay, well, 0.4, what is 0.4? I'm just going to write that down as a decimal first. That's 4/10, which is the same thing as 2/5. Okay, so the reciprocal of 0.4 is flipping that fraction around. The reciprocal is going to be 5/2. Okay, so the right hand side one is going to be 5/2. Now, what's the root of 512? Sorry, cube root. So, calculator. What is the cube root of 512? It is, of course, 8. I should have known that. So we've got 8 to 5 halves. Now we need to give the answer in the form n to 1. Now we don't have n to 1 at the moment. I've got 5/2 instead of 1. So in order to turn 5/2 into 1, I'm going to have to multiply it by 2/5 then, aren't I? Okay, and if I multiply that side by 2/5, I'm going to have to multiply that side by 2/5 as well. So 5 halves times 2/5, that's going to give me 1 on the right hand side. And then 2/5 times 8 is 16/5. Does that cancel down? No, just going to leave it as 16/5. So 16/5 to 1. You could write that as a decimal, but why would you? Question 31. Use trigonometry to work out the value of x. Okay, so I've got a triangle here. It's a right angle triangle. I know the hypotenuse. I've been given an angle and I want to find another side. Okay, so this is a job for SOHCAHTOA, isn't it? Which is our mnemonic for remembering which of the trigonometric ratios we're going to use. Okay, now 39 is my angle. This one over here, 20, we call the long side the hypotenuse, so that's h. Now x is next to the angle. We call that one the adjacent, and the one opposite the angle we call opposite. Okay, so which ones have I got? I've got the h side, and I want the a side. I don't know the o side. I don't want the o side. So anything with an o in it, I do not want. So I'm going to get rid of that one because it's got an o in it. That one because it's got an o with it. I'm left with that one. Cosine of an angle is equal to the adjacent divided by the hypotenuse. It's the cosine ratio. So I'm just going to write that out in full. Cos theta, cos of the angle, is equal to the adjacent side divided by the hypotenuse. Okay, so now we've worked out which ratio we need to use. It's just a matter of plugging the numbers from the diagram into that equation. Okay, so theta is the angle, so that is my 39. So cos 39 is equal to adjacent. That's the thing that I'm trying to find. That's my x value. And then the hypotenuse, that's the long side of my triangle. That is equal to 20. So I get cos 39 equals x over 20. Now I'm trying to find x. So I want to get rid of this 20 down here. So I get x by itself. And I can do that by multiplying both sides by 20, can't I? Because they'll cancel on that side. And I'll end up with 20 cos 39 is equal to x. Okay, so now I've got x by itself. I can just simply type that into my calculator. 20 cos 39 equals. That comes out to be 15.5 to 3 significant figures. So I'm just going to write down 15.5 centimeters as my final answer. Now, it's a good idea at this point, just because it's a little bit complicated, isn't it, trigonometry, is just to imagine that value that you've calculated does it look right in the diagram? Remember we were finding that one, weren't we? The adjacent. So does it look like 15.5 there? Well, we can see the long side is 20. So yeah, it's a little bit shorter than the longest side. That kind of makes sense. I'm kind of happy with that answer. But you know, before you do move on, it's always a good idea just to look back at your diagram and think, well, does it fit? Does it make sense? Because you can catch a lot of errors in your method that way. It's better to spot an error in the exam than find out you made a mistake when the results come back. Okay, I believe that's it. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.